Hey, Keeney coming to you with another tool review Autel scope video thing. This video is going to be about as dry of a topic as it comes. So this one really is just for the nerds. You want to see some insights to the oscilloscope, but we do skip over a couple details, but because I'm going to save those for another video. But if you want to see some intro stuff to this scope, it is a pretty cool scope. It's a little buggy from time to time, which is frustrating, but this is going to be one boring ass video. But I hope it helps somebody. You can see before you maybe make a big purchase, because these things are kind of pricey, you know, budget relative, of course, but if you're looking to get a new tool, sometimes these things can be a little bit expensive. And at least with this, hopefully you can use some of the info in here to compare against some of the others that you're looking for and make a decision that helps you get whatever data recording requirements that you have for your application. That's all this is really for, just so people are kind of shopping around, don't want to make a purchase but get some extra info. So enjoy this video. She's a dry one. Now that we got the scope powered up and we're doing this, camera on screen deal, I know this glare is terrible, but I want to be able to point to things on the screen without actually touching things on the screen so we could talk about it, but I don't actually have to make the selection. So that's where doing an actual screen share or screen record here I don't think is going to be useful. So we're just going to have to deal with this glare the best we can. Well, first we're going to go over and find our measurement section, and there we're going to have our oscilloscope function. I will note before we actually open this oscilloscope, if you do not have the VCMI connected, whether Wi-Fi, Bluetooth, USB, whatever, the VCMI icon in this lower toolbar will have that red X. So you can see there's our little red X right next to the VCMI icon. Means we do not have the VCMI connected. If you do not have the VCMI connected and you select the oscilloscope, you will get a window that pops up. It says you cannot connect VCMI immediately or enter demo mode, or excuse me, you can connect or enter demo mode. You want to enter demo mode. And for all the stuff that we're going to start off here, we're going to actually use demo mode. If you just click OK, it starts to stream data across the screen. The data that it streams across the screen is pretty much their default, but what I will tell you is, at least with this current software release, and it does change from time to time because Autel makes changes to this stuff for better or worse, the presets that you have on your various channels and the template that you have saved or load up on default for when you open the scope will show up. What I mean by that is my default settings on this scope are saved so that all 4 channels are turned on and every channel is on a 20-volt scale. So we've got -20 at the bottom, 0 or ground middle, and 20 at the top. That's the range that it opens the scope in. Also the time base. So we have 5 seconds per division. That gives us, so each one of these individual, I don't know if you can see it very well on the screen, but there's a little hash or little squares that go all the way across the screen. Each one of those divisions is 5 seconds. That is just how my settings are saved on this particular tablet, and so that's how it opens it on. But demo mode, the actual signals that are being broadcast across right now on all 4 channels, that is going to be our demo. So I said so. We're probably going to say so a whole bunch in this video. We'll just have to eat it and keep moving. We'll get to the rest of this first, but I want you just to know that if you open yours in demo mode or you see somebody else open theirs in demo mode, the scales may be different, the time base may be different. That pulls from the user preference, which we will go over, but the actual signals that are being plotted across are going to be what they call their demo. The main scope screen is broken up into 3 main sections. You have the upper toolbar, which is just all the buttons across the top in gray. The main view section, which is just everything in white. in the middle, and then on the bottom we have what they call the lower toolbar. Not to be confused with the actual tablets bar, but just the channels, the triggers, the time base, measurement stuff, etc. Those are the three main sections. Moving across on the top of the upper toolbar, we have the, just obviously says scope. The little play button indicates that the connection status is there, whatever that means. And then you got this giant stop and play button. If you hit the stop, it'll obviously stop streaming across. We're in demo mode, and it'll freeze whatever data you got there. In non-demo mode, you can go back pages, but I don't think it works in this one. Anyway, if you want to start streaming again, you can hit play. They call that the start-stop button. Pretty straightforward. The next series of icons in our upper toolbar, this first one that has the little car on it is called a preset. This one is pretty cool if you're just starting to get into some of the more deep scope type analysis features. You can click this and it will bring in, like known goods of certain actuators, sensors, etc. And you can load those. And you can load presets for it also. For example, actuators, we're just going to go right across the top. Actuator, air conditioner, blower, we'll just click that. It opens what you should look for on this. So it's going to say for most of these, I'm kicking the camera, most of these you're going to see a 0 to 5 square wave. It gives you some general descriptions, which we can scroll down and see. It'll tell you in loose terms how to connect to these on a vehicle. Gives you a little picture, and then you can see you got a blower motor. You're actually pinning one of these out, pinned to ground. So it shows you a generic way to connect for each component. And it has this for each one of those presets that we just talked about. I don't remember if there's more stuff below. They do come with some real world picture examples. So this stuff's really cool if you're just starting to get into the scope usage, I think, and you're actually trying to learn it. I think they call it the demo mode, but there's a lot of useful information if you're just kind of getting started. Reading through all of this, it seems like a lot to read through, and it certainly is, but there's some good nuggets of information in here. It'll also give you some description operation of what type of signal you're looking at, what the load is, and whatever, subject to change. So when we loaded that template, you'll also notice it turned our other channels off and just went with one channel because that's the template that you loaded in. Now, if you wanted to, you can now connect the VCMI, and instead of being in demo mode, play live, and you can keep these settings that we've just pulled up. And in keeping these settings, I'm going to move this camera because I keep hitting my toolbox and shaking this thing. Only the greatest film quality, as always. I hope y'all love it. You're probably really bored anyway if you're watching me do a scope video. That's okay. It's always for the nerds. What was I saying? Oh, it'll keep these settings for if you actually want to connect the VCMI and then go do the read or measurement on a real vehicle. And you can collapse this window with this little arrow here, but it's got a couple other tabs. Gives you some basic information of what type of sampling rate you're getting, what type of scaling you have on that given selection, etc. And then the help function is pretty cool. A lot of the help function stuff is straight out of the user manual, so it'll copy and paste whatever you've got for this given section right here. And we'll get to more of this a little bit later, but anyway, we can collapse that with the little arrow. We can collapse that with the little arrow. There it goes. And so this is just the default we pulled up for that top one. We could do another one. Let's do something that's a little bit fancier. Let's do injector. And let's do, so we're going to do voltage and current. So this one should pull up more than one trace. Stuff like this is really, really cool to see. It's, our known goods or whatever. Even without reading any of the description, we can already tell that our channel A is going to be a current trace, because we can see right here we've got a little pintle hump and then a max current saturation. At the same time, our channel B is dropping from what looks to be about 12 volts to ground, so we're charging charging that injector up, trying to get that pintle to move, and then it releases, and obviously we have our inductive spike and our drop in current at the same time. And like I said, if you just connect your scope right up to this, this will set you up to take an actual live measurement on the car. Tells you what leads we're using, just all the stuff over here. So let's do the same thing. Let's click the diagram picture. They can show you how you have this thing configured, like physically, and then it probably will give us a real, they call it real vehicle connection, and what that looks like on a given vehicle. So we're back probed in here, and this glare's so bad. Oh yeah, there's the amp clamp. It's hard for me to see the amp clamp. This giant black piece over here on the side is our amp clamp going around that wire. Stuff like this is, if you're just getting started and you're really trying to learn, oops, click too high. In my opinion, I think this is a really good place to start. It's really helpful if you don't, it does take a lot of time to go through all of these and read all of this stuff, and but it's helpful. Descriptions of what you're looking at. So I haven't read, said so again. I haven't actually read any of these in a very long time, and then so I was going to give it a little quick read live here also. Before the injector's open, there's no current flow. Channel A is 0, which is what we were talking about. You know, channel A red 0, and the battery voltage is 13. So that's what we talked about, because this car's obviously running here. I said 12, but you know, same difference if you would for the purpose of this video. During the injection, current at channel A climbs to 0.5 amp. We can see that it's climbing up, and after a short slowdown shoots up to 0.8 amps. The slowdown point is around 1.5 microseconds. Suggests that the injector is completely opened at the moment. I think they're talking about this pintle hump here and the difference to get there, so we can see it and then re-rise again. So they described it a little bit differently, but that's basically what we're looking at. Anyway, related to ETCs, that's pretty cool. I didn't realize that was in there, or I forgot. Blah, blah, blah. Parameter info, just like we talked about before, it tells you your sampling, your scales, and settings for each thing that you're looking at. So if you don't know how that configured this automatically, you can see from the previous screen this changed from voltage to amperage, because we're taking a different type of measurement on this screen. So it gives you those readouts. You can load the defaults or memorize it in the future. Again, just kind of beginner stuff. Help, we've got same thing, part of the user manual pulled in there for whatever. This is how this first thing works. So what they call that again? The presets is what they call it. When you click that little vehicle in the upper toolbar. And there's a lot of good stuff in here. We can scroll down for several of these. It doesn't show you a scroll window or like a scroll bar on the side, so make sure you know that it does scroll down. And then this one does not, because we're already done. All kinds of stuff. These combination tests, cam crank, and these are all defaults. Obviously, you can configure this thing however you desire for your own testing. I do. I really don't use these defaults because I never know what I'm doing, and it's just faster for me to go in. I know what I want. I pick my presets and move forward. Boom. So that's all stuff on this first icon here called the preset. Moving to the second tab, this is the waveform library. This waveform library for Autel is not as extensive as Pico, though I would report probably nothing in existence is, but you can load and save waveforms on the actual device itself, as well as save it to Autel's cloud, and you can allow, when you load it to their cloud, that allows other users to pull in the references. You can search for different vehicles, keywords, whatever. But you can, like I said, you can also save it to the actual tablet itself. If you save it to the tablet itself, you can load it in as a reference waveform, which is super helpful. So you got OnLive waveform library, can't see. On the left here, on the right here, it says local waveform library. These are just ones that I have saved. If this was a brand new tablet, this would likely be empty. But these are ones that I have saved. While we're here, I'm just going to load a reference. I think it will work in demo mode, and since we had that previous trace showing up as like injector testing, I don't know if it'll delete it, but there's two different ways that you can load these waveforms. You can load, when you save a waveform, it saves obviously whatever channels you were recording, and you can load the whole waveform with all the channels, or you can even load a specific channel. So I don't remember what this was. This looks like, just staring at it close, I think this was ignition switch testing. So I'm just going to pull in channel C, which goes through some various ignition. And so, I said it again, this is hilarious. I'm going to say it a lot this video. Right here, we've got 4 different links. It says load as reference waveform. Each link is for each individual trace that previously was recorded. Open will open all of it. I'm going to go ahead and load just one of them. And you can see right here, we are also zoomed in really far. It changed it to a weird color, and you'll see down here at the bottom, it's hard to see, but this says ref, R-E-F, right at the bottom. And you can see this blue line here is what I'm looking at. So if I had taken, maybe just as a random example, let's say this previous waveform that I just loaded was injector number 1 that I'm suspecting, and then this new recording that we have loaded up for channel A and B is injector number 2, and you want to compare the two, you can load in one channel and actually see that one channel difference. Pretty cool feature. I do use this, not all the time, but I actually do use it quite a bit when I'm saving waveforms and loading them back to compare results. If you watch one of my, like the one video I loaded this off of was the Chevy intermittent no crank. If I had not saved that waveform that we just pulled up, I don't know that I would have been able to have a super good, conscientious call on what was wrong with that vehicle. Saving these waveforms is super helpful, and it definitely saved. It gave me the confidence to make the right call the first time on that vehicle specifically. That was waveform library, and really those are the main 2 tabs. The online, you can search, check your uploads, favorites, all that stuff and whatnot, and these are just random ones. I don't really like the lacks in the naming conventions of these. A lot of these are not, they allow the user to input what they want to call that file name. So it's not like you go in and select your year, make, model, engine, trans, build, blah, 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 and save a waveform for that on the online section. It just kind of gives you your own little customization. And I think that's a little bit of a dirty way to do it, because if you don't know what somebody else saved it as, or they spelled the saving name wrong or whatever, it makes that waveform harder to find. I really don't use this a whole lot. I've looked for 1 or 2 in past, and the frustration that I just talked about is what I experienced. It's not easy to find exactly what you're looking for, because they give the user some ability to name their own files in their own personal manner. Local waveform library, like I said, this is just what I have saved. So these are all references that I have saved. I don't recall what the notification is for. You might be able to set notifications. I don't remember. You might be able to set notifications for waveforms that are populated. I don't remember. I really don't remember on that one. Moving on down our upper toolbar is the next icon is our settings gear. So you can click settings. This is how you set up the main window view below. There's a couple different ways that you can show this. I will probably do these, at least these lower 2 will be their own standalone video. Oscilloscope view versus record view. I actually prefer oscilloscope view better. They really do the same thing, but record view just gives you an extra window at the bottom that you can play back more than one screen on. So if I select that, we were obviously already in oscilloscope view, but if we go through, and now let's hit play. Again, just demo mode stuff going. You can see our actual view screen here at the top is only about a 1 second window. So I've got, if I pause this, I've got, looks like 11 seconds and 12 seconds. So we have a 1 second span here. And then on the bottom, you can see we have a total of 12 seconds recorded. I can then move this here to wherever I want to go in that recording, and then I can zoom in and do some analysis there. What I don't like about this at all is you are limited. Well, I actually fixed this. But anyway, depending on how much data you're recording, you are limited to how much. Oh, yeah, you can only do 30 seconds because it resets. I hate this. Yeah, maximum time, recording time is 30 seconds. That really bothers me, especially on the testing I do. I do way more than 30 seconds of data, and I go back and look quite a bit. When you're doing it in the other view, it just depends. It's got like a total buffer size on how much data it will record. So if you're recording a high sample rate, all 4 channels, it'll fill up fast. But if you're recording a little bit less sample rate at one channel, it'll record a lot longer. This may change. I don't remember if this changes if we do that same type of thing. In any case, the one feature about this particular view that is nice is you have this ability. If you're only within your 30 seconds of recording or whatever, you have the ability to move an event that you want to look to the center of the screen. What I mean is, let's say the event that I'm recording data, blah, 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 and the event that I want to particularly look at is right here on the edge of the screen, and then it goes off the screen and goes into the next one. If you're not in record view, you will have to tab back and forth between the last screen and the previous screen to see what is going on there. Whereas here, let's say, I don't know if I can bring my cursors in. Yeah. Let's do it this way. Let's say this cursor 1 is where my event occurred that I want to expand the data on here to really look. If this happens in the non-record view, you're stuck with expanding to here and then going to the next page. And the next page, the cursor would be over here or off the screen, and you'd be trying to analyze stuff here. When it comes to the record view, we do have the ability to actually move over a little bit so we can see, that would move that event here in the middle of the screen, and we can blow it up a little bit better. The record view is very useful for that. I don't know if I can do what I'm referring to in demo mode. Oh yeah, I can. Perfect. So look, we can see down here, these are the number of frames we're recording. We have a 20 millisecond screen right now, so 0 to 20. If I hit stop, perfect example. Let's say this event here where we're going from, what is that? I don't know, negative 50 volts to 50 volts or whatever. Yeah, so it's just a 50 to 50 square wave based on demo mode. Let's say I want to see the other half of this transition. I can go down here and click back one screen, but you'll see now I'm limited to just that screen cutoff. So if I wanted to view, event here plus another 2 milliseconds to the right, what I have to constantly do is bounce back and forth between these 2 screens to try to get that last little data. Whereas if this event here, actually we could just say it this way. Let's say I wanted to capture the whole time it went to negative 50 and it's on 2 different screens. I have to constantly bounce back and forth if I'm trying to really see some detail over here. Whereas if you're in the record view, you could move that little slider across and then you could center essentially. So we could more or less zoom in. You could do this, it stops, but you could center this cutoff in the middle of the screen and have much better analysis based on that one little, on that one event that you're looking for. So that's really the main difference that I have found between oscilloscope view and record view. Again, we just have the ability, actually we probably, yeah, whatever. You get the idea. You can move it. You're smart enough, you can figure that out. XY view and spectrum view are going to get their own videos. XY view is not something that I think a lot of techs will be using. If you are using XY view shoot me a message, leave me a comment, because I want to talk to you for a while about what you're using it for. The only thing I could really see XY view being useful for is if you're doing some sort of audio or speaker tuning, maybe some amplifier tuning. That's about really about the only thing I could come up with. And we don't really do that a whole lot in our world. We don't design speakers. We don't design, PID controls um, uh, whatever. Anyway, we don't do a whole lot of that as far as doing repair work. Spectrum view is cool. And the only time I use spectrum view is when I'm doing NVH analysis, because it gives you a totally different way to look at the data. Those are going to be their own. Maybe I'll loop them both into one, because I probably won't do very much on XY view, but spectrum view is cool in my opinion. I really like it, but it's kind of confusing if you're not used to seeing data aligned in that manner. Next one down is window function. You can configure a few different windows if you want to have, like so. Come on. So you can split out your channels by each. I don't know if I said that. I probably said it in a very poor way. Let's go back to this one, window function 3. So we obviously have channel C off, but you can turn channel C on, and then you can turn channel D on, but you only have 3 different ones, so it groups them into 3. If you want to see all of these in different windows themselves, you can obviously do the 4. That should be pretty self-explanatory. Let's go ahead and hit play. And let's change this a little bit. I think we may have broken our demo mode. I don't think demo mode's going to work in this way. Oh, you learned something new. Let's go back to display 1. And in this case, our demo mode should come back. We broke it! That's funny. This happens. This scope is buggy. And if you watch my intro to the Autel tools or MaxiSYS, whatever, like the tablet overview, I talk about how buggy the scope is. And it's true, it is buggy. We're going to close the scope. So we hit the multi-function, multi-window, recent window, whatever. We're going to close out of the scope, go back to our measurement tab, reopen the scope. It should ask us if it does. We are going to enter demo mode. We're back in demo mode. Let's go ahead and hit that window function again. Let's see if it'll allow us to split it and play. Okay, now we're working. And if we look here, looks like channel 4 is overlapping channel A. That's how that works. And we still have our ability to squeeze these down, like so for each one. I'm trying to minimize the scale, do my little custom thing. It's kind of hard to do. Anyway, this is what that looks like. So we broke the scope. That definitely happens more times than you think it should. There we go. Now we're looking good. I'm going to jump in here with a feature that I realized I overlooked in the video. So this is actually coming to you as a cut-in. When we were configuring our display mode, there's also a channel settings tab over here. So specifically right now we have 3 windows selected. We can see in the background channel A and channel D are on the same trace, and then B is its own, C is its own. If I wanted to move one of these channels, I can do that through this this channel settings menu. So let's take channel D. It's in window 1. I can move it to window 3, so it'll jump down, and you can see that now happen. So you can configure what trace you want to share with which other graph, just based on, actually I don't think, I might be able to. Let's see what that does. Yeah, so you can configure this pretty much any which way. You can have certain traces on certain window screens, however it suits your fancy. Going back to our settings, the waveform generator, dang it, do have to have the VCMI attached. Please hold. Thanks for holding. We have fired up the VCMI in the other room, and it might take a second here to connect. We'll see. Note that our VCMI is showing as a red X. I actually just hit the button and brought up the VCMI screen. We are currently trying to connect. It's trying. It's thinking. It's taking forever. I just heard it beep. There, we're connected. Let's do recent windows. Go back to the scope. Now it says, hey, we detected the VCMI. now will allow you to do other stuff. We can then go in and select waveform generator. The waveform generator is pretty cool. You can do several different types of signals. The only thing that I've ever used this for really is ABS sensors. When you're trying to figure out, is the computer, do you have a wiring issue in between, do you have a bad sensor, whatever, you can plug in, do the waveform generator, actually pin it to the ABS connector, send a signal based on what you input here into the computer, and then you can go to PID data and actually see if the computer is detecting wheel speed signal. The other way to do that too is, spin the wheel and then or run jumpers from one wheel sensor to the other wheel sensor and then spin the other wheel. And if you get, that good signal, So for example, let's say we have a left rear speed sensor code and the right rear works. You spin the right rear and you get a good signal. If you take and jumper wires and run the left rear harness to the right rear sensor, now the computer doesn't know that the right rear is actually hooked to the left rear. Then you can spin the right rear and on PID data say, hey, does the left rear PID data change like it's supposed to? Now your sensor's in that wheel, whether it's a tone ring or sensor or whatever. That's really about all I've used this for. I don't use it for it very frequently because it just takes a little bit more time than actually running those jumper wires I talked about. But the other one that it actually comes in really handy with is if you want to hijack a frequency-based MAF sensor. That's the only other time I've come across that this is useful. And so let's say you've got, I think GM's super sensitive on their frequency-based mass airflow sensors. If you think that the MAF is skewed, you can run down the road. This is a lot of work, and I know it's probably just whatever. We're just talking about what you can do. We won't get into the actual use cases. But if you know what the frequency should be and you've got fuel trims out of whack, you can go in here, hijack those signals, go into the PCM or engine computer, whatever modules can getting data from that MAF sensor, and then create your own and then see if your fuel trim's correct. So the great diagnostic for that as well, though it is a little bit more invasive. And can we turn this on? Yeah, we can. We have different ways that you can generate it. So square wave, I forget what the difference between square wave and square wave XY is. Triangle wave, actuator wave. Basically, you want high load, you want duty cycle, whatever you want is what you can input. So let's do a square wave. This is going to say 5 volts, 1 hertz, duty cycle 50%. Let's go and drop this down. I think we can enter our own numbers. Let's do 15 or 13%. So you can see just the difference. And then I think we just close out of that. Now we can actually see, can we start it and watch it? I don't actually have the scope hooked up, but anyway, if we had the scope hooked up, you could see your feedback here also. But it brings up this little window that you can do your controls with. And I think we can move this around. Yeah, we can move it around. Frequency generator is pretty cool. Obviously, everything says 0 because we're now connected to the scope. Because we're now connected to the VCMI, and the VCMI doesn't have any scope leads hooked up to it. It's just sitting open, so everything's reading 0. I'm going to disconnect. Actually, I'm going to go turn it off. Please hold. VCMI has now been turned off. You can see it says disconnected there. Let's go back to the scope and go back to our demo mode. It should give us an error. Maybe. Play. You can connect. Let's do demo. Boom. Now we're back to our demo mode. Alright, where would we leave off? Somewhere in here, settings. We did waveform generator, so that was previously grayed out. And then when we powered up the VCMI connected Wi-Fi, the waveform generator icon became enabled. That's what allowed us to select it. Decode settings. I used this on one of my recent videos on, actually I think that same Chevy we were talking about earlier with the ignition switch stuff. This is how you can actually convert the binary CAN network or other communication network, but the binary changes that you see from time to time, if you ever pin those out, to actual hexadecimal messaging. And then with hexadecimal messaging, when it's converted to hex, you can do a little bit more analysis if you're kind of up on that. I don't know what we're going to be able to do here in demo mode. Let's just set this up and hit OK. Yeah, and it's not going to pull anything because our signal, I'm going to jump down here to our time base. I'm going to zoom in pretty far. Oh yeah, we have the wrong type of signal on channel A. It's not going to work. Let's try and set that up on channel B. I'm going to change my time base back out. I know I'm jumping around a little bit. I'm just trying to get this settings to work for the purpose of this specific function, and then we'll go through the rest still. But let's do channel D. We'll do can, hit OK, because we've got square wave on D. Yeah, so square wave, it's not going to tell us. Anyway, well, if you go check out the other video, what it can do is it can take the CAN messages that are typically square waves, and it will convert those binary changes, the highs and lows, to hex, and then it'll run the hex conversions down here. You can also expand this window out, and it'll show you all the CAN messaging. This is a cool feature of the scope, but it's not really useful if you don't have the intellectual property to decode what the hex then means for each individual parameter on the vehicle. Maybe you can do some reverse engineering, but it's not easy. It's very difficult with this. We probably won't do too much of that. But anyway, you can see if you watch the other video, or here, hold on, I'll overlay a picture of the other video. Now you should be looking at something from the other video, and it's got a bunch of messaging going across. All right, let's get rid of that picture. I'm still learning how to do video editing, a bit of a knuckle dragger, but I think I can make that part work. Moving back to our settings, that is decode settings. I'm changing your binary changes on a CAN network or whatever other networks that they do. So CAN, LIN, FlexRay, UART, they don't do most, it doesn't look like. NFD, yeah. So most all the ones that you're gonna have on most vehicles. There's some probably won't be able to do this based on what I'm seeing. FlexRay though. I don't know if you're gonna be able to do some media stuff, like infotainment media. Some of those data buses are like super high speed, like Ethernet, most, whatever. I don't think you can do those, but most of the other module to module communication stuff you're gonna be able to get away with here. Cool feature, but if you don't know your module ID and you don't know the CAN frame for the data packet that you're looking for, it's not super useful for the stuff that we do. And it's less useful because we can't really export it to Excel and find a delta of, if you plug a module in, take a recording, unplug the module, take a recording, and see what that difference is. We really need that ability to filter those IDs, and you can't do it with this tool that I figured out how. So cool feature, but there's not much real world use case that I think anybody in a shop is going to use anytime soon. Startup settings, this is what we talked about when we first opened this window. I had 4 channels on, 20 volt scales. You can configure it how you want and then save it as the startup configuration, but you've also got factory, blah, 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 and you can save more than one. So this is currently set to load user default, and that's what I did. I set everything at 20, turned everything on, 20 volts, turned everything on, saved it for my user name default, and that's why it pulls it open. Demo settings, this is cool. You can actually go through and change what parameters are available. So let's go ahead and change channel A from a sine wave to an ignition signal. And then very loud cars going by. And then let's also change channel B to an ignition signal. So it only gives you 3 options, and you can also set the speed for whatever. Let's up this a bit. We'll do 4,000 RPM. Now when we close out of this, we can see we have ignition signals on channel A and B, and then we have a sine wave on channel C and a square wave on channel D. We can zoom in quite a bit more to actually see what that looks like. Let's hit the pause button. We can see very clear firing lines. Should be able to zoom in all of this too. Come on, zoom. Zoom, I say. I gotta click it first. Oops, I broke it. So again, demo function, there it goes. A little fidgety sometimes, but we can very clearly see, grounded line, spark line, or fire line, spark line, etc. And then obviously this is curved, this is squared. Let's zoom out a little bit. You can see probably 20 should be fine. So that's what that looks like. You can change the demo settings. And one thing I wish you could do on demo settings is do trigger work, but the trigger's always grayed out here. Yeah, it doesn't let you do it. It gets grumpy. That is all of the settings that we've gone through. Next is on our top upper toolbar is the math function. This is cool to me. I don't use it all the time, but there are certain times where it becomes super useful. In any case, it just has some defaults. So formula is what it calls. So if you want to invert A, let's say you've got, let's just do that. We'll invert A. Let's say you've got a current probe and you want to see, it's only going the wrong direction or whatever. I'm just making stuff up. It's, you got the polarity switched on your current probe and you want to see it different. You can invert that channel, but you can also create a synthetic channel where you go in here and actually see that. So if we look at, there it is. We've got this synthetic inversion on channel A. So pretty cool stuff. You can do basic math as well. I don't think, can we do like D? I don't remember. Let's do it this way. I'm going to try something and you're going to watch me fail live. Let's reconfigure our channel A to sine wave, channel B to square wave, and then in our math channel, let's do A plus B and play. Yeah, so you get this super wonky looking signal. It's pretty cool, I think. Again, most of the time when I'm going to do stuff like this is, we won't even get into it. But my point is, having math channels to do between different other channels is really cool. So this is channel A plus channel B. And in this case right here, we can see channel A is approximately, oops, I pulled in the wrong cursor, my bad. Channel A, by the way, there's cursors on the three corners of this. So I pull cursor 1 down from the top and it tells me that's 10 volts. If I bring in cursor over here, it says this is 20 volts. So that means our calculated channel, our blue, should be approximately 30. And it is. I don't know if I don't think I can bring cursors down. Yeah, I can't bring cursors down. That's a bummer. Oh wait, hold on. I did that math wrong, didn't I? So 10 volts over here plus 20. Yeah, it should be about 30. I don't remember where I just left off. I was doing a whole bunch of measuring and then got confused. Let's do this again. Let's take our channel A here. Let's squish it down a little bit and bring our cursor into the top of A. So we have 10 volts on channel A. Let's do the same thing with channel B. We have 10 volts on channel B. So 10 plus 10 is 20. We can do our math right. And so I'm going to take our synthetic channel, A plus B, and move it up to the top. And you can see, right, it's about touching the top. And over here, if you can see, it says 20 volts. So I have the ability to do math with any given channel. These are just defaults. And I believe you can change the colors. Yeah, no, maybe not. Anyway, you can also define your own. This is pretty cool. How if you want to do your own math on a specific way something's working, then this can also work for you. Let's get rid of that. Moving over to our next section, this is files. This is where you can open, load, save your waveforms, etc., etc. You can save configurations, like we talked about how to load the templates. That's what all of this stuff is. So if I wanted to save this waveform, I can, or open any of my previous's. When we looked at, I think we were doing, I forget what we were doing over here when we were talking about the waveform library. So if you wanted to, let's say we wanted to save this waveform into the waveform library, I could hit save waveform. Now it's going to ask me a whole bunch of information that look very similar to what we viewed previously. and then I can load that in at a later date. If I want to load in a waveform, all I do is hit the open, and then same for configuration. So if I wanted channel A and B to be a 20 volt scale when I open the scope, but I want channel C to be a 50 volt and channel D to be a 100 volt scale, then I could just select those settings, and then I hit save the configuration, and it would save it off as such. So here I was trying to be fancy, and I said A plus B, but I was doing A plus, no, cut that out again. Their question functionality, if you would, is super helpful. There's in my opinion, good reason to actually go through and read the owner's manual. It is very helpful. This last little icon over here is going to be your sample. So how often is it taking samples? I think you can input, yeah, you can input your maximum. I forget what the maximum is, but if you want to change your sample rate for all of the channels, you could do it here. So if you have something where you don't need a super high sample rate and you want a longer buffer where you can go back and replay that data, you can just dim that down to something lower, and then that'll work better for you so you can actually go back and collect more data. There's an auto scale function, but I don't know if it will work, and oh, it will work. So if we hit auto scale, boom, it re-zeros about everything close, and I don't much care for this auto scale function. There are several occurrences where we'll back up a little bit. Does it work? Kind of. If you have some erratic patterns, then it doesn't work very well. And usually when I'm using the scope, I'm looking for some erratic stuff. So I don't really like the auto function. You can still come in here and, zoom in and zoom out to get your own scaling. And I believe you can still set your own. So yeah, it's getting a little grumpy with me. Anyway, auto scale function does exist. It's not my favorite, but it does work. Next in our little order of operation, we talked about the top toolbar. Now, as we've been going through stuff, you've probably gotten a pretty good idea of what this main window looks like. But there are a couple things that I wanted to try to point out if I can do successfully. Let's go back to one window, get everything there. This little light bulb over here on the right is really cool that Autel has put in here. It will take whatever screen you're on and pull a help for that particular screen or the last thing that you touched. And if I can try to remember how to get this to work the way that I wanted to show it, I don't know. This might be a disaster. Let's go to decode settings. So just something we've already previously done. Now we're gonna hit this little light bulb again, and it tells you what in the settings mode. There it goes. Oh, we're already there. Anyway, it'll actually go through and it pulls the help menu for what particular section that you are in. Let me try to think of another one. Let's go and hit our change scale stuff, and I'll hopefully give us the same one. Yeah, so here's different help sections based on what we were just on. There was something else, I don't remember. Anyway, when you hit this little icon, it gives you a whole bunch of help for whatever button you just clicked. So if you're somewhere in a menu, if I remember correctly, this will give you some details behind that menu. And I thought that was a cool little trick that they did just to offer. In our main window here, we obviously have 5 channels because we still have the math channel on over here on the left, this dark purple or whatever. That's our math channel that we got going on, which is goofy and cool, but whatever. Let's go ahead and get rid of this math channel. for the purpose of our demo. So math channel is now off. We're back to just our 4 channels. On the screen, there are 3 different ways to bring cursors in. You can do an X-axis cursor for your time base. So I can drag them to this yellow lower section of the square wave, and it can tell me position of cursor 1, position of cursor 2, and a delta of the 2. So I got 7.55 seconds between the 2 cursors. Likewise, on the top right, I can bring in a Y-axis cursor. So let's go from the bottom side of this yellow trace, the yellow square wave, to the top side of the yellow square wave. It gives us the same stuff. Position 1 is negative 2.52 volts to 2.46 volts with a delta of 4.98 volts where these 2 cursors are. Lastly, for our sets of cursors that we've got on our 3 corners, we have our angle cursors. I forget exactly what Autel calls them, but something angle measurement, angle something, whatever. Anyway, this one is super handy if you're doing a little bit of, I'd say a little bit more in-depth engine mechanical evaluations. We can take this a couple different ways. Let's say point 1. Well, let me start with this. This angle meter that I've got down here, the blue one, says 0 degrees, and I guess it's more purplish, but the second angle meter cursor we've got drug in defaults to 720 degrees. So that means we can assume, let's say we've got a pressure transducer in a given cylinder of an engine, and these are the pressure waves that come through throughout. Now I know it's going to look totally different based on that, but just humor me with the demo mode analogy. To say that, for the example, let's say this is cylinder 1, and here at my first cursor angle meter, let's call it top dead center, cylinder 1, so let's call that compression stroke. That means this next one here would be top dead center exhaust, and then we'd be at top dead center compression again. The difference between these 2 cursors naturally is 720 degrees of crankshaft rotation, and then it shows as such right down here, so 0, 720. You can also edit these cursors and bring in a couple other segments. That really is helpful if you're doing some sort of piston overlay chart. If you're trying to figure out when intake valves, exhaust valves are opening, it becomes super handy. Let's start with the basics. You can touch each one of these. So I'm going to touch the 0 degree box down here, and I can input whatever value that I want to. If I'll just leave it at 0 for me, I don't ever change the first cursor off of 0. I don't know, I haven't come across a scenario where that's more helpful, but you can set the base value to whatever you want. Let me show you a better example of that on the other side. So we already said if this is 1 cylinder, we can say this is 720 degrees of crankshaft rotation. Well, maybe I want to say that this point is 360 degrees of crankshaft rotation. I accidentally clicked it. I can then touch that box down there. I can go in and change this to 360. Confirm. And so now it says 360 degrees. This comes in super handy when you start dragging in these other T1 and T2 cursors, because it will break up the degree difference between the 2. Likewise, I'm going to drag those back off screen for a moment, clear it out. Let's go back to our 720 example. The other thing that you can do in this mode, when you hit that edit box, the ruler value, you can actually add more segments, more visual segments between the 2 cursors. If you've seen a piston chart, that's exactly what we're getting ready to overlay. So I'm going to hit 4 segments, confirm. Now we can see we have 3 extra rulers that have been drawn in with 4 actual segments in between. And as I move 1, they all extend in the same aspect ratio, which is super cool. I like that. Now, to bring in the extra points, if I drag in my time cursors again, T1 and T2, I don't know how easy it is to see, but it actually tells me the degrees from 0 that each cursor is at. So cursor 1 right now is at 98 degrees. Cursor 2 is at 280 degrees. Also gives me a delta degree. Let's move this out. I'm going to move these back just for now. But if this were, we're trying to overlay or figure out when exhaust valve, if you have a very weird pressure waveform, like for an in-cylinder pressure transducer, and you're trying to figure out what's happening where, now we know that, okay, well, if this was top dead center, our first one, this is top dead center compression, we know that this downstroke or this downward trajectory of the data is going to be our power stroke. Likewise, this upward trajectory, which would obviously be much smaller in a real world example, would be our exhaust stroke, and then we would have our intake stroke, and then back to our compression stroke. And then to see the degree difference of, maybe we had an anomaly, right here, let's say we had an anomaly just after bottom dead center, we could say, okay, well, how many degrees after bottom dead center did that occur? We drag in our cursor 1, we can see cursor 1 is at 213 degrees. That means we could do, 213 minus 180, that'd be your degrees after bottom dead center that you have that event. So maybe your exhaust valve is delayed, or you have a sticking exhaust valve or something like that. Now you can actually see the degrees of rotation, and if you know the cam specs too, then you can just compare it to that. But anyway, being able to do this type of cylinder analysis is super, super tricky. And I shouldn't say tricky. I meant tricky. Trick as in like cool. It's super awesome to be able to have this functionality. I wish we could run different apps in this program, because I do have a piston overlay chart program on my computer that I'll also overlay in some of these. Maybe here I'll throw in like a picture of a previous example where you can overlay it. But to do the overlays, if you actually are trying to, because if you get, well, I'll state this to my own experience. When you're trying to keep track of the valve opening events on intake and exhaust valve for 4 different cylinders at a minimum, you start to get lost because you forget the firing order, and then you've always got different pistons in different positions and different valve openings at different times, and it gets a little confusing if you're trying to do it all in your head, for me anyway. And so 4-cylinder is pretty basic, but if you do something even fancier like an 8-cylinder or 10-cylinder, man, there's so many valve opening events and so many different cylinders at different engine positions. Doing this type of breakdown and having that overlay really just comes in clutch to try to figure out some more base engine issues. So I think that mostly covers everything in this segment. We can just, for fun, if you wanted to add, and you could add up to 10 splits in here. Let's just add 10 because we can. Confirm. Now you can see we've got a whole, we've got a whole bunch of different splits. So if you actually wanted to add this in to every time you have, I don't even know, we could speculate. I could speculate a bunch of different ways to use this, but suffice it to say, you can customize your segments as much as you want, up to like 10 sections, I believe is our max number. Yeah, 10 values. Cool feature, definitely like it. 2 things. I just figured out my mic's disconnected, so the audio is probably terrible in all the other frames, but I'll do what I can and edit it. Anyway, back to this. We have our screen recording, or our trace recording, for 45 seconds. We got 45-second cursor here. Let's say I want to zoom in to the let's say the 15-second mark. Let's say there's an event that happened at 15 seconds, and I really want to see more detail of what happened at 15 seconds. I'm really zooming in. That's too much. All right. Here you can see 14.9 seconds, kind of, because there's a glare. All right, I got phone calls and stuff. I don't even remember where we were going. Something about we were zoomed in. So we have like a 45-second trace we recorded. We are now at our 15-second mark of that 45 seconds, zoomed in. If I hit the replay button, what you're going to see is there will be nothing on this screen for 14.7 seconds. That's our first cursor here, or our first data point here. it just stays zoomed in. I wish there was a way to re-zero our time base to the default selection that I picked previously, and it frustrates me that there's not, because I always touch this screen in this manner. Maybe it's just the way that I use it is not how Autel wants me to use it, but anyway, I'm going to hit play now, and you'll see we have nothing playing. We're still in demo mode. Data is streaming right now. We're still on 5 seconds per division, but it's going to take 14 seconds, almost 15 seconds for that data to finally start coming across. And you'll see this whenever it does come across. There it is. I'm going to go ahead and hit our stop button. I'm going to call that, what, 2, 3, 4 seconds after 15. So we should see when I zoom out, our actual data will have 0 to 15, and it'll also have 15 to somewhere close to 20 when I zoom this all the way out. And there it is. So we have, at our last data point here, 18.9 seconds of data. This always messes with me when I'm recording or doing triage on vehicle, because I'm always recording, zooming in, and then hitting play. So like here, we recorded this. I want to see what happened on this screen here. And then I'm like, okay, I'm ready to watch it again. I hit play, and I got, my screen's off. And if you're not privy to this, if you have an intermittent event that you're trying to capture, and you actually want to see it, you may miss it here. So you have to like play, hit stop, zoom out again. Anyway, the way you fix this is hit play, and you have to hit play, and then you come back, and I can't even just touch this 5 seconds per division again. I have to select something else, select the 5 again, and then go back to the screen. Now you can see we've got our 5 seconds per division. Just a little personal gripe about zooming in and out of the actual tool itself. Lastly, we're going to move down in here to our lower toolbar. I think I might do a separate video on this last icon down here. Moving down to our lower toolbar. Obviously, we've got our 4 channel selections here, and if the color's on, then it is an active channel selection. So we can see that channel D is obviously on. If I touch the D itself, it goes away. And then we can see we still have these other 3 channels spitting data out, and you can turn each one off and on individually. Let's go through the actual active channel selection menu. It stopped. I turned it off. When you turn all the channels off, it stops it. If you hit the little box or rectangle next to the active channel that's on, now you can configure this however you want to. So we can see that we've got a 5 volts y-axis scale, so it goes from positive 5 to negative 5. If I want to change that to 50, I can click 50. I don't know how well you can see this, but it goes from negative 50 to 50. Depending on whatever measuring you're doing, obviously you want to pick your correct scale. And probe settings is the next one. This is how you get some of the other probes set up and plugged into the actual VCMI and get to report on the scope, whether it's an amp clamp, whether you need to run your 20-to-1 attenuator because you're doing ignition coil testing or whatever. This is where you can figure all of that stuff. You can see X1 is just multiplier of 1, so it's whatever it is. If you're doing ignition stuff, you hit your 20-to-1 actuator, changes your voltage scales in the background too, and that way you don't hurt your scope. I believe I'm gonna have to put on the screen whatever the max voltage is. It's something like 200 or 300 volts that the scope can handle before you need an attenuator. And if you don't adhere to that, you can damage your VCMI. I think Autel can fix it though if you send it back to them. Anyway, 4 different selections for the 2 different current clamps that you can order. I don't think these come with the tool. I think you have to order a separate kit. And then you got your coil on plug ignition probe and your secondary ignition probe. So if you actually want to clamp on the spark plug wire versus just holding the wand over a given coil and actually watch some tracing there. I'm less than impressed with the coil on plug ignition probe. That said, I've never really come across any coil on plug probe that I've been impressed with. I'm always going to back probe it to the best of my ability. I know some of them you can't, depending on circuit design of that coil, but it's just kind of a pain in my opinion. Anyway, user defined probes. These are awesome. If you watch I think the video is the world's most expensive tire pressure gauge. I did a demo on how to create select your own custom scales. So I have a 200 psi gauge pressure transducer, also a 50 psi absolute pressure transducer that I use for different stuff. So I can run those pressure transducers into the scope, select these, and they'll actually spit out a psi value. We can just do it for fun on the next one, and you'll see how it inputs the change difference. This EETA 501C is actually, oops, you can't even see, is a snap-on current clamp that came with my snap-on the DVOM, and I also wanted to be able to run that here. So I have a conversion for that amp clamp to be able to spit out correct amperage, easy to read, etc. here. So those are the three probes that I've configured on my own. If we just go back to the screen, we can see that we've changed the scale already from negative 631 to 618 psi, and it's just a psi rating. That was, probe setting, user defined. And then this one, I know we can invert that math channel previously, but this is super helpful when, especially with current stuff, if you're doing, actually really anything ignition related, but if you're always checking current and you flipping that probe around to different circuits rather than undisconnect that probe, flip it upside down, connect that probe again or amp clamp again, you just come in here, hit that inverted button, it spins it for you, so you don't have to do it that way. This is a very, very nice little feature, very small but very useful. I use that all the time when I'm using amp clamps. Probe edit, here is where you go in and actually make your own user-defined probes. It's in the probe edit section. You create the new name, give the y equals mx plus c, they call it formula, however that works. Low pass filtering, this is really cool, and it actually does a really good job of picking, it's not going to let me do it in demo mode, I don't think, but if you have a super noisy signal, if you remember previously, we're talking about our sample rate up here, so we're doing, this is 500,000 samples per second, I believe, and you can up or down, I'll get rid of this, you can increase or decrease this, but this will change all of the probes on the screen. Whereas here, when you go to low pass filtering, if you're getting a noisy signal, you can select each individual channel to put a low pass filter on. Super useful. I use it quite a bit, and actually I've played around with all the different settings in here, and 3000 hertz sample filter is pretty good. They just default all to 3 kilohertz, but it's actually a pretty good default. And I usually just, if I get a noisy signal, I just come in here. Oh, it turned on that time. That's nice. But anyway, let's see if it actually did. Oh, it's a clean signal anyway. It'll make this signal much more clean when you're trying to do that stuff. Super useful. I like that a lot. Next, we cannot use, we can't use our trigger in our demo mode. Please hold. We can now see our VCMI is powered on. Man, these cars are so loud. These cars are super loud driving by. Our VCMI is powered on. We can see we got green down here. It's connected, and so we are streaming data across the screen right now. It's just 0, but you can see it tracking across, and we got 50 seconds of data. But this will now allow us to do our trigger. So we can turn a trigger on, and wherever that blue dot shows up is your trigger point, and you can move it accordingly, however you want to. Hit the little square wave button. This is where you set your trigger. Auto works pretty well for the most time. When I'm doing this, I will typically, the only thing I really change in here too much is whatever channel that I want it to show up on. So you have to have your other channels on, so we can see C is off, A, B, and D are on. Now I can go in here, I see A, B, D for my trigger selections. I do obviously change that quite a bit, but I leave auto most of the time because it's going to throw it somewhere in the middle of the screen, and I just drag it real quick to wherever I want and whatnot. But you can manually put this stuff in also. You can select it, repeat, single, none. So if you got a high threshold and you want to capture the first event, whenever it comes up and hits that trigger threshold, it'll just stop, or you can have it streaming across the screen. Like if you want to watch ignition coils, you can get your time base set up so you only see 4, 6, or 8 coils at a time, and it'll always just repeat that way. however you want. It's pretty useful. I won't get into that. Never mind. Trigger function really is basically pretty basic. Moving on to the next thing, we've got our screens, or our let me move this down a bit. Let's do one. So this is how many screens you're recording. So we started at 0 seconds. We've got 10 seconds across the screen, and oh, you can't even see this because there's a horrible glare. But this, there it goes. It says 1 of 1. Now it says 2 of 2. So every time this trace goes across the screen and goes to the next screen, it will then update this here, so you can see how many screens of data you're recording. So now we're on 3 of 3. So I can hit stop. And let's say I want to go back and view something on screen 2. That's where I hit the back arrow right here. I don't know how well this shows up on camera, but now it says 2 out of 3. So this is screen 2 of 3 that's recorded. I can hit it again and go back to screen 1 of 3. Hit play again. Obviously, we've been messing with our time base throughout this whole video. This does go down to the nanosecond, which is pretty trippy. That is a lot of data. When you get down in this data sample here, like 100 nanoseconds per division, I do believe you have to be USB'd in, and you can see how fast we're screaming across. This whole screen here is 1 microsecond. So 0 to 1 microsecond. That would be 0.000001 seconds across this entire screen. 1 nanosecond is 0.000000001. So this thing takes some seriously high-res data, but when you're doing this in real life, not in demo mode, you have to be USB'd in to get that much data collection. It doesn't do it over Wi-Fi, and you're limited on your buffer to like 1 to 2 channels, so you can't do all 4 channels at this rate. But the fact that it does go down that fast is pretty awesome. I cannot say that I've ever used something in the nanosecond range. I do get to the microsecond range from time to time, and obviously the millisecond range I'm a heavy hitter on. I use milliseconds and seconds constantly, very rarely, but occasionally. I believe when I was doing some CAN decode and stuff, I got down to the microsecond range, but it's pretty rare where I get down to the microsecond range. Oh yeah, one other thing that I forgot to go over here. That was just the basic trigger. When we go to our trigger function, there are several other functions that you can do in here to really define what type of trigger that you want to get. It's pretty cool. Hysteresis function is super cool. I don't really use this stuff though based on what I do, but the ability to do these is pretty awesome. Like, for real, pretty awesome. You can code in your own I would say sample type. So if you have a specific type of signal that you're looking for, you can, let's say we want to see spark firing lines that exceed 50,000 volts but have a fire line of, I don't know, less than a certain amount of seconds or whatever. I can configure that. So if I have a misfire, I have a good event, I can actually configure the trigger to pick up on those. It gets to be a little bit much to me, especially for the stuff I was just talking about. It's way easier just to, record wherever and then zoom in after. But the fact that we do have the ability, oops, let me zoom, you may have to go back in pretty far for it. I don't remember. Yeah. So you have to zoom in pretty far to be able to use these other things. But the fact that it has the ability to look for this is super cool. I don't know how many people are really using it. If you are, somebody does, have them send me a message. I'd really like to know what people are doing here, just out of curiosity, but it's not something that I've really found a whole lot of use for in auto repair. Our final icon down here in our lower toolbar is what they call measurement. We're going to have to go back to demo mode for this. So let's go ahead and just disconnect that. Let's go back to our scope. It should give us an error. We'll click OK as we want to enter demo mode. There. Now we're in demo mode. We're super zoomed in though. Let's back this out a little bit. We have square waves, sine waves. Yeah, looks like 2 square waves and a sine wave. If you come down to the measurement tool, now we can do some analysis on those waves. So we have channel A selected. Let's just go ahead and do positive duty cycle ratio and then hit exit. And I'm going to minimize that down a little bit. Now we can see we're exactly at a 50% duty cycle ratio on channel A. Let's turn B and C off. Let's also go into our demo mode. I gotta remember where it is. Demo mode. Let's do, oh yeah, it won't let me. Never mind. Anyway, whatever kind of, it'll do calculations based on this. What I actually think I'm going to do is for this measurement button, there's so many functions in here. There's so many. I'm going to do a standalone video on this for each one of these. I don't think this should be included in the actual video itself. One thing I forgot to mention, I looked over, you have this zero screen. What that does is it re-zeros your ground part. So if I move this off screen for whatever reason, like I lose it, let's say I moved it up too much, like, I don't know where my cursors went, it's off screen somewhere, it could be above, below, whatever. You can come over here, hit this re-zero, and it brings that ground point back to the center of the screen. I do believe that it also works with multiple channels, and it only shows up after you actually turn on the channels. So I'm going to move several of these channels off the screen. So we have several channels off the screen, move that one completely off, hit re-zero. Oh, it only brought it in. So you have to select which one. So now I'm going to select red, re-zero, green, re-zero, and then it goes away. So now everything's re-zeroed. But yeah, I think that covers most of the scope functionality overview. Hope this was helpful for someone. I know it's super dry and super boring, so if you stuck out, you're a real nerd. Congratulations. Eventually we'll do some other videos that are specific to the other functions, such as the XY view and the spectrum view, and I think this measurement tab down here will do individual ones on. The measurement one down here, the reason I'm going to do it standalone is I don't think I can really do it in demo mode, and I'm going to have to create some sort of bench setup to actually show some of these. Some of these are pretty advanced, I would say, for like a normal scope analysis, and I want to try and do it as best justice I can. But that's all I got for you. Hope it was helpful. I will catch y'all in the next one.